multiple subsystems. So a quick recap of what we've learned so far, and there ang immediate previous na topic was performance specifications or precisely time specifications for second order system. So detailed kay to siya nga analysis of control systems. Now, since we're targeting breadth of coverage sa topics, musa ka ta balik to a more overview type of topic, and this involves multiple systems na. So that's why the title here is reduction of multiple subsystems. We know how to analyze second order systems, but in reality, rare ka na siya. Idealized siya nga second order systems. It's a good starting point to understand control systems. But most of the time, the real world, most of the time, di gyud na siya inana ka simple. Complex yun na. By complex, daghan of parts, meaning. So ang outcome ng topic is perform the reduction of multiple subsystems into a singular system. So there are concepts you need to understand, but these are relatively simple compared to what you've been through in the previous topic. So dali ra ni siya. There are three topics we'll cover. So just you can ask questions at any point. So we have components of LTI systems, fundamental connections, and three, manipulate blocks or systems to create fundamental connections and overall reduce the system into just a singular block. Now, just to recap, when we talk about systems, they are represented mathematically by the transfer function and graphically using symbols. So in figure A here, we see one of the symbols, arrows. These represent signals, and they have labels. R of S is we're still talking about systems in the frequency domain. So we still have R of S as the input, C of S as the output. Figure B is an entire system. What I mean by this is na natatong rectangle na nasa sud ang symbol for the transfer function. Remember that the transfer function is also just a ratio of the output over the input. So all in all, I hope maka-remember mo. So again, we're moving back a little bit in terms of concepts. Nisakata sa overview, not detailed so much. So a new thing you might see is figure C. The circle with a cross at the middle, inside of it is called a summing junction. The summing junction essentially just, as the name implies, sum or combine the signals going into it. So this is defined by the typical signal symbol plus included with a symbol near the arrowhead or close to the summing junction to indicate the sign of our signal. Positive ba siya or negative. And the result of a summing junction is just the algebraic sum of the signals going into the summing junction, into the symbol. Directly converse to it is the pick-off point, where you take one signal and distribute it sort of separate. So kanisha, we're not breaking apart a signal composed of multiple components, but a single signal is distributed. Copy siya of the original signal branched off. So mo na siya nga pick-off point ang term. So branching tani towards other blocks. At the end of these arrows could be another block or a summing junction or another pick-off point. So these are the basic components of linear time invariant systems in control systems. So that's first topic. Dali ra no? Second is we're now talking about the fundamental connections. Fundamental meaning the basic. Other connections or diagrams of subsystems is just a combination of these connections. So the first type is the cascade or the series connection. So this is just as the name implies. A signal is basic ni siya. First part. Edit, comment. So this part here is the basic symbol kanina. The result DI can also be represented not just with an R of S, but with a new signal X sub 2 here, which denotes the product multiplication ang nahitaboan ni. So R of S times G of S gives us C of S, or in this case, gi-assign na nato siya bagong variable X sub 2 of S. Now, when we take the signal and pass it as the output of this block is now the input of another block, the result is still the same. The operation is the same, multiplication. So we take this signal, x sub 2, multiply it with g of 2, sorry, g sub 2, then we get this one again. This will continue on as long as you have this series connection. So any signal passing into the block diagram or the block of a system is multiplied to the contents of that block. And overall, we can simplify this or we can reduce this instead of three blocks down to just one by multiplying every block inside, every system or every representation of system inside the block series. Next, we have the parallel connection. So in series, we're just using the arrow and blocks. In parallel connection, we're using all of the symbols now. The arrow, the block, the pickoff point, and the summing junction. So let's start with the pickoff point. Pickoff point here, R of S, will be distributed again, as I mentioned earlier. So every output of G here, the blocks, is represented by x sub 1, x sub 2, x sub 3. And the arrows is also equal to R, the signal that was being picked off and passed as the input to this block, multiplied. And typically, when you have a pick off connection, they will at some point combine together with a summing junction. So the summing junction here adds all of the signals. So mathematically or algebraically, mo niya ang porma. You need to take note of the uh, sign of the signals going into the summing junction and use it accordingly here. Multiplied by R times G plus R times G sub 2 minus R times G sub 3. So be aware. If wala siya na-indicate, you need to ask or clarify unsa na siya nga signal. So the reduction of this is just the sum, algebraic sum of the signals or systems going into the summing junction. Give me a minute. Okay, asa ganito. So, yeah, kung you have a parallel connection, you're just adding the blocks along the path. Kung unsay ning sud nga sa aming unsay nga sud nga blocks sa aming junction, i-add ra nimo together. Last but not the least, feedback connection. So, the feedback connection is one of the most applicable or dako kayo in significance ang control systems nga or systems that are implemented with feedback na loop or feedback na connection. So let's break this down. We have the input signal always an input signal or the input signals are always on the left and output signals are on the right. In between is our system. So usually we have an input transducer. So the example I used earlier was the antenna katong pag-introduction na unsa may gamit sa control system dahil it allows us to control a very huge system, a huge antenna pointing to the azimuth angle of to the sky. Uh, to make life easier for those who need to use the antenna, a control system will allow you to use a convenient form of input to adjust the output or the angle of the system. So sa kana nga situation, in that context, we need an input transducer because the input is a knob, angle siya, rotating a small device, and the output is moving a very large mass. So along the way, we need to convert some of things. So a transducer is just similar to conversion. So we take that input angle to, let's say, electrical signal. So that's the input transducer. But essentially, this becomes a value, and that value is passed on to the summing junction. And take note of the symbol; it's a positive value. So meaning, ang range of input sa ato ang signal is positive. Wala tayo expect of negative values. And from there, at this junction, we also notice nga naatay lain nga input. And I'll get back to this later. So the sum of these two signals is outputted, and we call the label now is E. E stands for error. Since we have a feedback connection, it has a way of determining if the output is actually what we want it to be. So there is, by standard operation or by the nature of having control systems, naging na error imuhang system. And the goal of the feedback connection is to reduce that error by design. Dili ka mo magsalig sa performance ng system. Di ka magsalig sa steady state error, di ka maghuwat kung sakto ang settling time. We can improve the performance by using this type of interconnection of components. So the E signal here is passed to our controller and in cascade with the plant. So controller, I hope that the as from the name, this could be an electrical or an electromechanical system that takes our error voltage signal to and then converts it to something that will move the azimuth angle of the antenna. So mo na siya point aning feed forward. Sorry, this is not feed forward. This is the forward path of our feedback connection. After that, na kay output. So meaning na angle change ang imuhang antenna. We take that angle change, we measure that and pass it into an output transducer and a feedback block. So this will just change that output. This you could increase that output, differentiate it, integrate it. So there are different ways to design a feedback control system that I hope makaabot na, but as of now, more dili. But this type of feedback loop is categorized into three types. We have the proportional, the FP, proportional feedback loop, uh, integrated na feedback loop, or derivative na feedback loop. Or altogether, derivative combination at mga types of feedback loop. But in general, altogether, they're called the PID controller. The form of that PID controller is this feedback loop. So, yeah, when we look at the arrow, positive or negative. So that means the error here has a chance of being negative and being positive. What does this mean? This means that for some reason, the antenna could be moving too much or too little from our desired input. So, mo ni siya ang feedback connection. So, we have certain definitions here. I-simplify na siya in figure B. So, mo ni ang ideal actual. But in this subtopic, we want to simplify that into this. Meaning, simplify na to. Of course, we know that the two cascaded blocks can be simplified, and H in the feedback loop can also be simplified by multiplying them. And using a new variable, we now have G and H representing the forward path and the feedback path. So the forward na transfer function and the feedback transfer function. So the formula ani is this one. The final reduction of the third connection or third fundamental connection or feedback connection is this one. So the derivation is here. So there are two equations we need to use. We want to figure out the block diagram of the system. No, again, the block diagram of the system is just uh, all of these interconnected using algebra that we know from a few slides ago. So what do we need to know? We need to know C and we need to know E because C is the output and C is also output of the entire system, but C is the input of our feedback path. So we need an equation for that. And for our forward path, we need the equation for E, the actuating signal or the error and the output. So we need those two equations. Definition nato sa C is the output is simply E times G of S, E times G, and the error is at the summing junction, outputs atong summing junction. So ang summing junction is the sum of the R and siya. The output of H is C times H. So wanang minus plus C times H. When we substitute E into the first equation, so let's have this as equation A and equation B. When we substitute equation A into equation B, this is what we get. We distribute ang G and the second and next step. So we now have two terms. The goal here is to get the simplified nga transfer function. That means we need to get the ratio of the C over R. C over R is the simplified system. So we get this after the distribution, we now multiply or transfer to the other side ang minus plus. So mo nang na-change ang symbols here from minus plus to plus minus. So na-invert man, no? So transferring it to the left side of the equation. Then cross multiply, rewrite everything. We now get the final answer or the simplified formula of the transfer function as plus minus 1 or G divided plus minus G over H. I'm just omitting S because I don't have a thick kog agi. Isag online, but igapon kog agi. Pasaylo ako. Next is we might need to use we can also simplify this system according to the forward loop. So we want to solve for the forward path na transfer function. Siya. So essentially the same round process. What is the equation that can be used to simplify that one? So that's equation A. So when we use equation A and divide both sides of the equation by R of S, the input, we can get this equation. 1 plus minus plus HS quantity C divided by R, or excuse me. We also know that the transfer function of the entire system is defined by C over R. Substitute nato I think we are replacing C over R with this equation. This fraction here is replaced with a known equation, C over R. So we can then use, or we can have a definition of the forward path transfer function as this equation. Gikan aning a derivation. So substitute ani, and then distribute G of S, H of S, na ma-cancel out, simplify siya just simply to this one. So we have two equations for um, the feedback connection. And that's the end for second topic. Any questions so far? Let's move on to the final subtopic. We have block diagram algebra for summing junctions. Now, as we have discussed, simplified ni siya or ideal ni siya nga situations where the given system is very it has the requirements to perform the reduction or simplification. Now, in cases where that is not ideal, we can then rely on these uh, operations to make it to make the interconnection easier for the reductions. So we start off. This is categorized according to the junctions, the summing junction and the pickup point. So when you have a summing junction and there are blocks close to it. So in figure 8, we have a block in the output or at the right side of a summing junction. The rules or the operations when you want to move this to the left is on the right side. Oh, sorry, is beside this entire equation, entire diagram. So this results in, if this is from the output or in the right side going to the input left side, you just copy the block to every input branch here, every input signal. So kung dapat ay third branch going in here, you would have to make, you would also have to multiply, you also have to copy the the block here on the right side. Another situation where you need to move blocks close to a transfer, close to a summing junction is if it's from one of the input paths going to the right of the summing junction. So from the input to the output, operation ana is you copy the block on the output arrow and you take the inverse of that block and copy it to the other branches. If napasa ni siya third branch again, you will need to copy an inverse. What I mean by inverse is 1 over G or 1 over the transfer function inside the block. But on the output side, direct copy ra siya. So these are the two operations on a summing junction. Left to the right, right to the left, or left to the right of a summing junction. Um, that's why the reason why this is called algebra for summing junctions is that if you look at this mathematically, we're just using the rules of arithmetic, katong distributive or commutative, but to siya nga kuan. You can correct me asa atong. But if you look at C, kaning first equation mo ni ang nasa left side. So C is equal to uh, R plus X multiplied to G. Mo man nato nasabtan, di ba? When we take a signal, if a signal is an input to a system, C is just a product of G and this signal. But this signal, in turn, is the sum of R and X. Mo ni siya. Now, in math form, in equation form, we can just distribute this. So we can take G, have it be a product of R, and G have it a product of X mathematically, or in this expression, if we take this and represent it as a block diagram, it looks like this. So that's why ang basis adding ato ang graphical na moves or algebra or operations is based on mathematics. So walang algebra for summing junctions, but used graphically. The same can be said for the second situation. when you have a block on the left side or on one of the branches, and you want to move it to the output of your summing junction, naagihapon siya basis on mathematics. So the algebra for pick-off points is relatively the same. Ang logic ana is the same. So when you have a block in one of the branches of the pick-off points and you want to move this to the left, um, you take the same block and move it to the trunk before the pick-off point, and you take the inverse of the block and move it to the other branches. So ang equivalent na move from right to left for pick-off points is this one. So if you follow the path of the arrows and katong basic transfer function nga block diagram nga representation of transfer functions, this is equivalent to this one overall. Yeah. So ang logic ani is reverse, no? It's sort of the logic sa right to left, but here it's sorry. Ang logic sa left to right sa summing junction is the logic for right to left of the pickoff points. Lastly, we have very simple. If you have a block before a pickoff point or to the left of a pickoff point, you want to move it to the right after the pickoff point, you just copy it. The same man na siya ang result mathematically. So, di ba, R times G is this arrow. But since distribute nimo, every arrow here is the same. Now, if the block is here, you take R, distribute it to the G's or to the block diagrams. The output side here, the final three output arrows are still the same. So, these two, ko tayo akong itudlo ang screen. these two diagrams are the same. Equivalent ni siya nga move. So let's look at examples. I have two examples in this slide. So example 1, what do you think can we simplify here? Another thing that I asked that this example show is that if you have successive summing junctions here, pwede tayo siya ma-combine. And at the quick initial glance, duha ka block diagram in cascade or series, multiply ra, pero kani siya. This looks very close to the to the parallel niya connection, but questionable dire. In this example, and of course, mathematically, if we want to combine these two, we just need to add, or this arrow here is simply this plus this. Or you can take all of these two arrows and add it to one summing junction. And in fact, you can do this again in this third summing junction. So ang simplification that we can do is combine the summing junctions, and this will show that H1, H2, and H3 are actually in parallel. And obvious naman nga, G, siguro tudlo sa akong monitor. Obvious rasad nga G2, G3 is in series. But H1, H2, and H3 are now in parallel. So we can use the simplifications here and here. So muna ang next step. So this is the first step. Step 1. Step 2, or step B, sorry, to be consistent with the slides, is simplify na. So the two series connections, G3 times G2, and the three parallel connections, H1 minus H2 plus H3. Asa manigikan ang mga signs when you do the parallel. So, kanira, take note of the arrowheads and signs attached to it. So, H3, you factor out din yung negative. So, it's up to you if you factor out the positive. So, kung positive na siya dire, negative ang H1, i-follow niyo directly. So, ang gibuhat niya is, i-factor out niya ang negative na sign and it's drawn on the arrowhead. Okay ra sa niya. And finally, unsa may sunod nga simplification na ito ang ma-observe. Initially, ganina, I wanted to move this block to the right. Pero another way to do this is to simplify this one. This section of the system now is in feedback connection. Using the
Timer.
formula, we can simplify it to this form and ganahan ako napatay step D but gibuhat ni Ma'am Blas at the same time when we simplify this to one block it's just in cascade with G sub 1. So a cascade connection or series connection is just multiplication of two block diagrams. So muna ang gibuhat niya, simplify first ang katong right side, so-called right side, in using the formula of feedback connections, and then multiply with G1, wherein the final reduction of the system into one block is the numerator or all of the G nga transfer functions, and the denominator is from the feedback in the second to the last step. So, unsa may matake na taning example, if you have summing junctions that can be simplified, that's the first thing you should do. If you can combine, sometimes pwede po mo i-separate ang mga summing junctions to make a fundamental na form. Let's move on to the second example. Ito lang usahon ang mga questions. So, kaning, at a glance, the second example is more complicated. So, we have in total 6 blocks, 3 summing junctions. How many pickoff points? 1, 2, 3, 4. I see 4 pickoff points. So, again, the objective is to get everything into one block diagram. So, asa man ang pwede na itong buhaton? If we take here, starting from the left, di man siya ma-reduce. But if we look at the second part, wala gihapon. Now, on the third part, kani, na chance gamay, this looks very close to a feedback system, feedback connection. As long as usara ka buok input, usara ka buok feedback path, kani siya, muram ni siya ning skip forward na signal path, we can uh, we can simplify this by separating these summing junctions. Kung makombine na to ang summing junction, we can also separate it. And I think sa solution ni Ma'am Blas, gibuhat niya two things in one step, two operations. One operation is to separate, and the second operation she did in this solution is to move G2 to the left of the summing junction. So when we move a block to the left of the summing junction, kung branch ni siya niya, trunk ni, ang trunk is a copy of the block diagram of the block, and the branch is an inverse of the block you're moving. So mo ang nahitabo dire. So two things are happening at once. I-reduce ni niya to using the feedback connection and remove niya ang block to the left. Now, there's no problem with doing everything step by step, but dugay gid kay ka mahuman. So if you can, as long as you can follow your solution, you can do several operations in one step. Sagot ako by step here is a redraw of your modifications, or after performing the operations, you redraw your entire diagram. I would call that a step in one step in the solutions. Now, reduction of multiple subsystems, you can have a variety of solutions. We're not sure generic path. You can have different blocks before you get to the final block. So, pwede na siya nga multiple solutions to one problem. So, after that, kung sa may nahitabo, we now have this one. Let's move right for left. Atong tanawon unsay results sa simplifications. This one is now one single block. We can leave this alone for a while. Kani siya, in the next step, this could be a candidate for a reduction. And this one as well, candidate po ni siya for a reduction. Or, simplification. Kani siya, still too complicated. This does not look like any simple or fundamental na connection. So I think ang next step is to let's observe a little bit. Kani siya, this one is actually parallel, no? This is a parallel connection. We can add these two blocks together. Ang gibuhat, yeah. So that's what one it ako ning gi-solve sa board siguro step by step. One yung step daghan kay kog di gani maayo drawing sa board kay daghan kayo og erasures. So the next step or another thing another operation together is we move this block to the right para makombine ang summing junctions. So siguro we can add that as one of the guide questions when you're trying to analyze the reduction of the system. Can I combine or remove summing junctions, or are there operations that can lead to a cascade form, parallel form, or feedback form? An option here is to move G1 to the right. We want to move this to the right so we can then combine these two summing junctions. These two summing junctions, combination of this will generate a form of the system nga dali ma-simplify. So that's what happened here. Two things, parallel, we simplify. So the branch is added to an arrow. If there is no block diagram in the arrow, you can represent it with a unity a transfer function. So nothing happens, the signal remains the same, or it's multiplied by 1. Yung simplification, the second simplification was katong gi-move to the right and gi-cascade. Two components no? Sa operation, two results or two consequences of operation. So when we move G1 to the right, copies output and inverse input branch. Input na path. And at the same time, kung na-move na cascade naman siya with G2, G1 will then be in cascade with G2, 1 over G1 will also be in cascade with H2. So gi-combine na sa niya mga cascade na blocks all at once. So na ay two operations, three simplifications for the I. If you take the cascade na simplification as as independent operations. And you see, we now have a cascade on the right side. This is now split cleanly in the middle. And this one, I think, iyahan yung simplify. When you simplify these, when you combine these two summing junctions, makaparallel ka nilang duha. Yeah. So, cascade, a product of the transfer functions inside, since fractions na siya, do not complicate it yet. Just use parentheses as your definition of the system inside the block diagram. So, I think third step or second to the last na ni siya, kaninga section now looks very nice, looks very similar, or is a feedback connection. Use the formula, you get this, and finally, fourth step gives you this, which at the end gives you this formula. Kung nata, kani siguro, simplify ta ni sa kuan. Very nice. Yeah. Any questions so far?
Sir, sa first example ba? What if ang naglibot ko sa kuan junction kanang what if negative to ang usa sa tulo ka junction, sir?
Kung negative ang tunga kani?
Balik sa katong first grid na sir.
First grid ani?
Kana. Puros man positive ang babaw. What if na usa negative dira, sir? Unsay metabuan?
Ang mathematics niya ba imurang i-follow, di ba? Positive ni siya so walay sign change, so nakanta ni labels ba. Let's call this F and X ayaw na S. R U ayaw lang. So nindot na ba? B A C ni siya, di ba? So C is the algebraic sum. So that's positive B minus A. Now C, E ni siya. So we take the combination of C and D is E. So kani siya plus since positive man ni ang D, is now equal to E. Ang last na to is, so lang, T na lang. T and U. So the last junction is the sum of the previous sums. So that's E. Since plus ang E, plus ta ni dere, since masabtan niya, wala na akong gibutang. Uh, and negative ang U, so natay minus U. Mo ni ang nahitabo, di ba? Sa signals lang. Now, if negative ang usa, imuharang E, incorporate sa imong mathematics. Negative ni, what if negative ang B? So, at the start, negative B minus A. Inig-abot na ko dire, pwede na ko i-distribute ang negative sa sulod. So, mahimo rin siyang negative B plus A. Nga, wala na ni sa kuan. Wala na ni sa gawa. Pero typically ba ang input sa kaninga form is positive, but if it's negative, i-kuan lang siya. I-incorporate lang ang sign sa algebra of combining signals sa saming junction.
Okay, sir. Thank you, sir.
That's a good question. So, napay question line? Okay. So, ang nahitabo ani guys, overdue na ta for the unit assessment and the summative assessment. So, try to keep that in mind. Ayaw i-cram o tuon. So, try to schedule study sessions kunuhay. If you do that. So, this is just a heads up. Ang assignment ani, associated na assignment ani, mo-chat ko Ma'am Blas tonight if when niya i-update. I'm not sure if iya ka na ning na-discuss or unsa. If ako ra ang update, I will change it tomorrow and I'll send the announcement. And deadlines, if ako i-update tomorrow, will still be the same. Si Ma'am Blas ra mo update, akong i-adjust ang deadline. Umuna siya. We are labot mi sa imong discuss ron sir. Dili, ang summative assessment is for atong time specification, sir. I think that's unit 3 based sa slides. This is label ba ni Ma'am Blas ang unit 4? Ano siya labot? There's too much if appeal ni block diagram. Task kayo ang solution for block diagram. So, unit assessment for katong mga time specifications and summative assessment or midterm exam na siya included na from the start until time specifications. I think nasa siya yung club programming na. So we need to do that in person. Kaya ba kung naagit tayo, majority of us have the habit of studying the day before the exam. Mas maayo if you study a week before the exam. Okay, una-una ha, mabundak ni tanan, matipo tanan exams. No moment pwede na may exam, ginay yung mga klase. That's I'm thinking end of the month, the last week of October. If not, after Holy Week na. Holy Week boy. Tawagan na. Kasi English na kalag-kalag. Which I dislike. I absolutely dislike. Lanyo na kaayo. Pagka kayo mong nakalimtan na. I want to have the summative assessment. Unit and summative assessment as soon as possible. Also all Saints Day. Yeah, para. Dagan siya kayo mahubog. Wala mo inyong duman. Wapilin yung hang knowledge sa kalag na may pass on. Ito na lumiya yung pahubog eh. Pakpod na. If wala na tayo questions, everything is clear. Jude, kumusta na ka, Jude? Okay na ka, Jude?
Okay na, sir.
Nice. Saan? Pera ka saan? Nag-uuna ka na ko saan?
Yeah, sir.
Okay, that's it for today, guys. Thank you for joining online and listening. For those who are listening, so yeah, stay safe. I'll post announcement for next week kung saan klase. Bye, guys.
Bye and thank you, sir.
Thank you,
Then
sir.
Bye and thank you, sir.